Summary of the life and career of Galileo Galilei, the founder of classical mechanics. Newton. Chapter 1, Childhood and Education, 1564–1585. Galileo Galilei was born on February 15, 1564, in Pisa, part of the Duchy of Florence, as the eldest son among 6 children of Vincenzo Galilei, a musician and music theorist, and Giulia Ammannati, the daughter of a merchant. His family belonged to the nobility but was not wealthy, and his father's skepticism of authority deeply influenced Galileo's scientific approach later in life. In 1572, when Galileo was 8 years old, his family moved to Florence, but he remained in Pisa with Muzio Tidaldi, a relative, for 2 years before reuniting with his family. In Florence, he was sent to the Camaldolese monastery in Vallombrosa, where he studied logic and considered becoming a monk. However, his father brought him back to pursue a secular education. Galileo early on displayed exceptional intelligence, particularly in mathematics and science. In 1581, he enrolled at the University of Pisa to study medicine at his father's wish, but he was drawn to mathematics after attending a geometry lecture by Astilio Ricci. He switched to studying mathematics and natural philosophy. Due to financial difficulties, he left the university in 1585 without earning a degree. While in Pisa, Galileo made a significant discovery, the isochronism of the pendulum. Observing a swinging lamp in the Pisa cathedral, he noticed that the time of each swing was consistent, regardless of the amplitude. He used his pulse to measure time, laying the foundation for studies on motion and time, a discovery later leading to the development of the accurate pendulum clock by Christian Huygens. Chapter 2, Early Career and Teaching, 1585–1592. After leaving the University of Pisa, Galileo returned to Florence and began privately teaching mathematics to earn a living. He studied the works of Euclid and Archimedes, developing a quantitative approach in contrast to Aristotle's qualitative methods. In 1586, he invented the hydrostatic balance, a device to measure the density of objects by weighing them in water and air. Inspired by Archimedes' Eureka story, he wrote an essay, La Bilancetta, the Little Balance, describing this invention, which earned him recognition in academic circles. In 1587, Galileo traveled to Rome, meeting scholars like Christoph Clavius and establishing connections with mathematicians such as Guidobaldo del Monte. These connections helped him secure a position as a mathematics lecturer at the University of Pisa in 1589, with an annual salary of 160 scudi. There, he conducted experiments on falling objects, challenging Aristotle's view that heavier objects fall faster than lighter ones. Although the story of him dropping balls from the Leaning Tower of Pisa may be legendary, Galileo did perform similar experiments. He demonstrated that all objects fall at the same rate in the absence of air resistance. He began writing De Motu, on Motion, an unpublished book in which he developed ideas about motion, refuting Aristotle's view that speed is proportional to force and inversely proportional to resistance. In 1591, his father passed away, leaving Galileo responsible for supporting his family, including his mother, siblings, and providing dowries for his sisters, particularly Virginia and Livia. This financial pressure prompted him to seek a better position, and in 1592, he was appointed professor of mathematics at the University of Padua with a higher salary. Chapter 3, Professor at Padua and Personal Life, 1592–1610. The period at the University of Padua was the most productive phase of Galileo's career. He described the 18 years there as the happiest time of my life. He taught Euclid's geometry and traditional geocentric astronomy to medical students but also conducted independent research in mechanics and astronomy. During this time, Galileo conducted experiments with inclined planes, using a grooved wooden plank to roll balls, allowing him to study acceleration in a controlled manner. He used a homemade water clock, measuring the amount of water flowing during the ball's roll, to determine time accurately. Through these experiments, he discovered that the distance a body travels under constant acceleration is proportional to the square of the elapsed time, a significant step in formulating the law of falling bodies. He invented the geometric and military compass in 1597, a versatile calculating tool used in military and civilian applications. In 1606, he wrote Operations of the Geometric and Military Compass, Lo Operazioni del Compasso Geometrico et Militare, a guide to using the tool, dedicated to Cosimo II de' Medici, whom he had tutored in mathematics. He also developed a horse-powered water pump and studied the pendulum, laying the groundwork for later timekeeping applications. In his personal life, in 1599, Galileo began a relationship with Marina Gamba, a woman from Venice living in Padua. They did not marry, likely due to social status differences, but lived together as a family and had 3 children, Virginia, 1600, Livia, 1601, and Vincenzo, 1606. Galileo deeply loved his children, especially Virginia, who later became a great source of comfort in his life. Galileo maintained contact with Marina and ensured her stable living conditions. In 1609, Galileo heard about the telescope invented by Hans Lippershey in the Netherlands. Without seeing the original, he built his own telescope with 8-fold magnification, later improving it to 20 times. He began observing the sky and made a series of revolutionary discoveries. In December 1609, he observed that the moon's surface was rough with mountains and craters, contrary to the belief that it was smooth. In January 1610, he discovered 4 satellites orbiting Jupiter, now called the Galilean moons, Io, Europa, Ganymede, Callisto. He named them the Medicean stars to honor the Medici family. He also observed that the Milky Way consisted of countless individual stars, and by late 1610, he discovered the phases of Venus, proving that the planet orbits the Sun, providing strong evidence for Copernicus' heliocentric theory. These discoveries were published in Sidereus Nuncius, 1610, a book that caused a sensation, selling out 550 copies in a week. Geocentrism is the cosmological model asserting that the Earth is the center, with the Sun, planets, and stars revolving around it. This theory was developed by Claudius Ptolemy in the 2nd century CE, based on Aristotle's ideas. It dominated Europe for over 1,000 years and was strongly supported by the Catholic Church during the Middle Ages. Heliocentrism is the cosmological model asserting that the Sun is the center, with the planets, including Earth, orbiting it. This theory was proposed by Nicholas Copernicus in 1543. In 1616, the Catholic Church declared heliocentrism heretical because it contradicted the Bible. Chapter 4, Return to Florence and Conflict with the Church, 1610–1632. Thanks to the fame from Sidereus Nuncius, Galileo was appointed chief mathematician and philosopher to the Grand Duke of Tuscany and chief mathematician at the University of Pisa, without teaching duties, by Cosimo II de' Medici in June 1610. He moved to Florence, bringing his 3 children, while Marina Gamba stayed in Padua and later married another man. Galileo continued his astronomical research, discovering sunspots, which he correctly explained as imperfections on the Sun's surface, showing that the Sun was not perfect and rotated on its axis. He published history and demonstrations concerning sunspots and their phenomena, Storia e dimostrazioni intorno alle macchie solari e loro accidenti, in 1613, further supporting evidence against the Aristotelian view of a perfect universe. He also observed Saturn, noting its strange shape, later identified as rings, though he did not recognize their true nature. These discoveries, along with his strong support for heliocentrism, shook traditional views and sparked controversy in academic and religious circles. However, his support for Copernicus' theory led to conflicts with the Catholic Church. In 1616, the Church declared heliocentrism heretical, and Galileo was warned by Cardinal Bellarmine not to teach or defend it. He temporarily complied, avoiding public debate on the issue. In 1632, Galileo published Dialogue concerning the 2 chief world systems, presenting arguments for both heliocentric and geocentric models. The book clearly favored Copernicus and was seen as provoking Pope Urban VIII, who had previously supported Galileo. In 1633, he was summoned to Rome by the Inquisition, convicted of vehement suspicion of heresy, and forced to recant his heliocentric views. He was sentenced to house arrest in Arcetri, near Florence. Chapter 5, House Arrest and Final Years, 1632–1642. Under house arrest, Galileo lived in his villa in Arcetri, near the convent where his two daughters resided. He continued working despite declining health and diminishing eyesight, becoming completely blind by 1638. During this period, Virginia cared for him through letters and emotional support. Livia, due to poor health, could not regularly care for her father. Vincenzo, now an adult, occasionally assisted him. He primarily lived in Florence. Despite restrictions, Galileo completed two new sciences, 1638, a work summarizing his research on kinematics and the strength of materials. In this book, he presented the laws of motion, including the concept of inertia. He recognized that a moving object would continue moving at a constant speed if no forces, such as friction, acted upon it. Although he mistakenly believed that the natural motion of celestial bodies was circular, his insights laid the groundwork for Newton's first law. He also studied the strength of materials, recognizing that larger structures are relatively weaker compared to their size, a significant contribution to engineering. Published in the Netherlands to avoid church censorship, this book is one of his most important scientific legacies. Galileo died on January 8, 1642, in Arcetri, in isolation but with an enduring scientific legacy. His body was buried at the Basilica of Santa Croce in Florence, but initially, no monument was erected due to church opposition. A grand tomb was built in 1737 to honor him. Chapter 6, Contributions and Legacy. Galileo Galilei left a monumental scientific legacy, shaping the foundations of modern physics, astronomy, and the scientific method. His contributions were not only specific discoveries but also a profound shift in how humanity approaches the pursuit of knowledge. In physics, Galileo laid the groundwork for classical mechanics through pioneering experiments. He used inclined planes to study acceleration, proving that all objects accelerate uniformly under gravity, regardless of their mass. He established that the distance a falling object travels is proportional to the square of the elapsed time, a fundamental principle of kinematics. Galileo also described the parabolic trajectory of projectiles, combining horizontal and vertical motion, and laid the foundation for the concept of inertia, recognizing that a moving object continues moving if no forces oppose it. Although he mistakenly believed celestial motion was circular, his insights paved the way for Newton's laws of motion. In astronomy, Galileo's telescope observations transformed our view of the universe. He discovered that the moon's surface has mountains and craters, challenging the notion that celestial bodies were perfect. He identified 4 satellites orbiting Jupiter, proving that not all bodies revolve around the Earth, a major blow to the geocentric model. By observing the phases of Venus, he provided clear evidence that the planet orbits the Sun, reinforcing Copernicus' heliocentric theory. He also studied sunspots, showing that the Sun was imperfect and rotated on its axis, and recognized that the Milky Way consists of countless individual stars. These discoveries not only challenged traditional views but also inspired future generations of astronomers. Galileo was a pioneer in developing the modern scientific method. He emphasized the importance of empirical observation and mathematical analysis, rejecting the speculative philosophical approaches of the Middle Ages. By forming hypotheses, conducting experiments, and using mathematics to analyze results, he established a research model that remains the foundation of science today. This method profoundly influenced scientists like Johannes Kepler, René Descartes, and Isaac Newton. Galileo's ingenuity was also evident in his practical inventions. He improved the telescope, enabling revolutionary astronomical observations. He invented the hydrostatic balance to measure density, the geometric and military compass to aid calculations in military and engineering applications. He also invented the thermoscope, an early device for measuring temperature changes, laying the foundation for the modern thermometer. These tools not only served scientific research but also had wide practical applications. Despite facing persecution from the Catholic Church for his views, Galileo's steadfast defense of scientific truth made him a symbol of intellectual freedom. He was sentenced to house arrest for supporting heliocentrism. In 1992, Pope John Paul II officially acknowledged the Church's error in condemning Galileo, affirming the value of his discoveries. Today, Galileo's influence persists in many fields. His name is given to Jupiter's moons, NASA's Galileo spacecraft, and numerous scientific awards. Galileo's life and work continue to inspire scientists and truth-seekers, reminding us of the power of curiosity, experimentation, and courage in the face of authority.